Hello, my name is Pyrskatsis and today we're going to talk about eventual consistency and what it means. So I have a shop API and it has a very silly logic. So we have a product entity and it has a name and a quantity, and we have a remove method that takes a quantity to remove and removes it from the total quantity. And then we have an order, and in our scenario, when we create an order, we pass a product ID, so each order can have only one product at the quantity of 1. And when we create the order, we add to the domain events a new order placed event, which, as you can see, it only holds the product ID. So in our event handlers, when we go to handle that order place event, we receive the product from the ID from the database, and then we remove one from the quantity, and then we save the changes. Now you probably have seen it work in something like that. If we go to my app.db context, before I save any changes, I take the domain events of each entity, and then we have some kind of event dispatcher. We dispatch that event, so we handle them at that time, and then we save the changes. So let's see that in action, but let me tell you that in my event dispatcher I have intentionally added a delay of 3 seconds for handling each event, so that we can visualize that there is a delay when we handle the events in that way. That could be the calls to the database, for example. So I have it run. If we go to my get endpoint, I'll get back an ice cream. So let's copy the ID. Let's place that in here. We'll hit send. And if we try to get them again, it has a quantity of 9. If we send that again, the quantity decreases, but we don't see the delay. So if I go to my event dispatcher, I forgot to add that. So let's say task.delay. Let's wait for 3 seconds. And let me show you also my program.cs, in which I have my 2 endpoints, the one for getting the products and the one for creating an order. So let's do that again, and I'll open Postman. Let's get the products. So we have again an ice cream. Let's copy the ID. Let's paste it in here, and I'll hit send. We wait for 3 seconds, and we get back our response. So we did it 2 times. Now our quantity is 8. So what we did there is what we call strong consistency. So let me show you that in this diagram. We have our client, we send our request, then we process the request, and then we make sure that our data is consistent before we send back the response. So in our scenario, we're processing also the events, and then we send the response back, which adds a little bit overhead to the request time, so the response is a little bit slower. And what eventual consistency is in our scenario, for example, we send the request, we process the request, so we save the order, then we send back the response saying it's okay, we process your request, and then we handle our events. So the time that we send back the response, our data it's not consistent, but they will be eventually. And it's not necessary that that happens in the application level, like in our example, handling domain events. It can also be in a database level if you have read replicas, etc. And you might want to do something like that if you decide that is more important for you and it leads to a better user experience. The API to respond faster than the data to be consistent all the time. So just to see that in action, we will make a simple implementation. So I will use a fake queue, and instead of handling the events, I will publish them to that queue. You can also use the ASP request pipeline and handling that event after the response has sent to the user. So even if you are using microservices and your domain events translate to integration events in some cases, you can publish them after the response has sent to the user, but we will keep it simple here since it's a video about what eventual consistency is and know how to implement it. So let's go and add a queue. Let's make it a static class, and we will use static lists of iDomain event. That's how fake our queue is. So public static list of domain event. Let's call that events and let's initialize that. And now let me go and do off the camera, so I don't bore you with the boilerplate code, a background task that will consume our events. So our background task is ready. The only thing that I do is I wait for 5 seconds each time, and then I try to see if there are any events, and if they are, I dispatch them with our event dispatcher. So now the only thing we need to change in our app.db context, instead of dispatch them before we save the changes, we only need to add them to that queue. So let's say queue.events.addRange. And let's see if that works. But first, let's add that background task. So let's say builder.services.add hosted service, and that will be our consume event background task. Let's see that now. I'll open Postman. We will get our products. And we have ice cream, so let's make an order for 1 ice cream. So there will be 9 after that. Let's hit send. The response is back in 24 milliseconds instead of 3 seconds. But now our products are still 10, and they will be for some time. So let's continue, and eventually they were 9. So obviously that delays, the 3-second delay, it's a lot. But it was just an example, so it can be easy to visualize. But I think you get the point. You need to decide what's more important for you. The data to be in a consistent state all the time, or it's okay to be eventually consistent after a small period of time, if that translates to a faster response. So that was all I had for this video. If you liked it, please like and subscribe. Thank you for watching, and have a nice one.